Hello, can you see my screen?
Yes.
So now we start. Today attendance is very poor. Only 40 or 50 student has joined. Whether now another class has, you have any class before this?
No, sir.
If no class, then how students are so late? They are joining one by one.
So the classes before were cancelled, so everyone is thinking that this class has also been cancelled.
Why? Because there is no notice or anything else, so why they will think so? And in previous class I have already mentioned that I will take another class. Okay, so whatever maybe we will start. Okay.
Okay, sir.
In previous class we have discussed the expansion of memory. হ্যালো
হ্যালো,
হ্যাঁ
হ্যাঁ আমি নিখিল বলছি।
হ্যাঁ বলো।
হ্যাঁ বলছি this, sir. Are you speaking right now? So you're not audible.
Okay. So now this is a 6 transistor cell. In 6 transistor cell, we can consider this Q3 and Q4. This can be considered as the load. Q3 is the load of Q1 and Q4 is the load of Q2. And Q5 and Q6, this will produce the gating network. That is, it is showing that X1, both are connected in X1. And this is the bit line, 1-bit line and 0-bit line, right? So these 4 transistors, Q1, Q2, Q3, Q4, form a bistable multivibrator. That means it has 2 stable state. When you consider this node voltage is high, then this transistors is on. And when this transistors is on, then this node voltage is low. So this low node voltage cannot on this transistor Q2. Or in other words, if you consider this voltage is low, that means this transistor is in conducting states. So its gate voltage is high. So when it is high voltage and it is low voltage, so this low voltage cannot on Q1. That means Q1 is off states and Q2 is on. So either Q1 is on or Q2 is on. Simultaneously, Q1 and Q2 cannot be on. That means it has 2 stable state. When Q1 is on, then one stable state and other stable state when Q2 is on. So now if we consider that Q2 is on, then we consider it is store 1. When Q2 is on, then we consider the bit 1 is stored, and Q1 is on, then we consider that bit 0 is stored, right? Now in a particular unit that we need to select that particular unit for reading or writing purpose. So that can be addressed the row line and column line. So to select this, we must select the row line, that is X1, and column line is Y3, that is X13. This particular unit will be selected. Now we assume that a 1 is written in this cell. We consider 1 is written in this cell. So according to our assumption, 1 is written means the node voltage N2 is low. That means Q2 is on condition. So when we consider Q2 is on condition, then we say it is 1 is written, right? And 0 will be written when Q1 is on condition. So first we consider that Q2 is on, so 1 is written. Now we want to read this data, whether 1 is written or not. So to do this, we first produce that read bar write, write bar and write. These 3 input will be 0 because these 3 input is responsible for writing in the cell. Now we want to read the cell, and this is the sense amplifier. This is the gating network Q7, Q8, Q5, Q6 gating network, and this is the read write sense amplifier, right? So this is the read write 1 amplifier, and this is read write 0 amplifier. So now 1 is written in the cell. That means Q2 is on, so that we want to sense. Now under this condition, to retrieve the data, to read the data, we must W bar, R bar W, W and W bar. These 3 input will be 0. So now if it is 0, then what will happen? This can be considered as the load. It is connected to VDD. So this load is connected to VDD through this point. Now what will happen? So that means this voltage is high. If this voltage is high, then these transistors will conduct, because these transistors can be considered as the load of these transistors. So this voltage is high, this voltage is high. So it will conduct. So that means this line, 1 bit line is effectively grounded, right? This line will be effectively grounded because this voltage high, this voltage is also high. So these two are conducting. So these conducting states will indicate that this line is grounded. So when this line is grounded, that means this voltage is equal to its supply voltage. So that means it is 1. So when node N2 is in low voltage, that's when this one is conducting. So this is indicates that this voltage is high because it is effectively connected to the ground. Sorry, a high voltage, right? So that means current will flow through this direction and also another current will flow through this direction. So that means this node voltage will be 0. So since read, that is S equal to 1, so we can sense that 1 is written in this cell. Similarly, if we want to write 1 in this cell, then we first put it here 1, then we will make it 1. So that means these two transistors are conducting. So if it will conduct, then this voltage will be low voltage. And if this is low voltage, that means it is grounded like this. So again, it will conduct, take current from this. So when it will conduct, then this voltage will be low. So if this voltage is low, then it will be considered as 1 has been written there. So like this way, we can read or write 1 in this cell. What I will mention here that are also present in this description. So this is configuration of NMOS transistors based on NMOS transistors. Now we consider the static RAM using CMOS transistors. CMOS transistors, it is basically the connection of two transistors, that is NMOS and PMOS. So this NMOS and PMOS are connected to form a NOT gate or a inverter. So this Q1 and Q3, it will form a CMOS unit. Q2 and Q4 form the CMOS unit. And these two CMOS unit means CMOS NOT gate. This is also NOT gate. And these two NOT gate are connected in crisscross manner. This is the output. This output is connected to its input. And this output of this CMOS output is connected to its input. So that means it is also produced a bistable multivibrator. And the other remaining part will be the same. So this is the getting network, Q5 and Q6. Then 0-bit line and 1-bit line are connected to your read, write, and sense amplifier that we have shown previously. So remaining part will be the same. Then what will happen? If we consider if this voltage is high, this output voltage is high, that means its input voltage is low. So output is high, this high voltage will operate at its input. So this is high voltage, so its output will be low. So this low voltage is connected here. And vice versa are also true, right? So that means these two NOT gate serves the purpose of bistable multivibrator. And this 4 transistor cell is inserted in this position. So then it will serve the purpose of bistable multivibrator for static CMOS RAM. So remaining configuration, reading and writing purpose are almost are same compared to your this one. So that is why I have not mentioned this circuitry here. Right. Then we consider that is dynamic RAM cell. These are the basic description of dynamic RAM cell that I have already mentioned. So here, this dynamic RAM cell, it is 4 transistors. Compared to your static RAM, the dynamic RAM has 4 transistors. So in terms of number of transistors, it is reduces. For a particular unit, it has 4 transistors compared to your 6 transistors static RAM. So in that sense, it will high density. In that sense, it is a high density chip. This is the another one advantage. Another advantage that in case of static RAM, it consumes power continuously. In static RAM, that is Q1 and Q3 are to act as the load. So it consumes power continuously. So consumption of power in static RAM is more. But in case of dynamic RAM, the consumption of power is less because it is not consume power continuously when you on your system, but it will consume power only on certain interval of time. Now, the construction. You see, there are 4 transistor cell, that is Q1, Q2, Q3, Q4. This Q3 and Q4 act as the load of Q1 and Q2, but it will take power for a certain period of time that I will discuss later on by considering these 2 transistors is clock signal. V is a clock signal and Q bar is the uh, responsible for refreshing this cell or all the cell in a particular column depending on the voltage V. Now here the information is stored in the parasitic capacitance C1 and C2. C1 is connected to the gate of Q2 and C1 is connected to the gate of Q1. So this parasitic capacitance can store the charge and that charge will act as the gate voltage. So that means basically your information is present in this parasitic capacitance. Now you consider this output is connected to its input and output of Q1 is connected to the input of Q2. That's mean it is a crisscross connection. So this crisscross connection indicates that it has 2 stable state. Either Q1 is on or Q2 is on, like your previous case. So for example, we consider Q2 is on. If Q2 is on condition, that means its gate voltage is more. So this gate voltage is more, so it is high voltage, so it will on and its effectively output voltage is low. So this low output voltage, that means the capacitor voltage C1 is low. So with this low voltage, it cannot be on. So that's mean it is in off state. And you see these are connected, so it can consider as the load at the same time. So now under this situation, if this capacitor voltage, there is a leakage, always parasitic capacitor has always a leakage. So during this leakage process, the charge stored in the parasitic capacitance C1 and C2 are reduces. So if the one state voltage is reduces continuously, then after some time it will goes in the comparable of zero state voltage or below the zero state voltage. So that means your data will be lost. To retain the data in a certain interval of time, you need to refresh this cell so that the one state voltage will goes to its high stage and zero state voltage goes to its low stage very quickly. So to do this, there is a arrangement of transistors Q and Q bar. So this Q and Q bar base is connected with some clock signal. So this clock signal, when the on period of this clock signal is present, then it will conduct the current, and this current will flow through these transistors. That's mean you have to, when you want to refresh, then you have to select that particular row and column, then this current will flow through this, then after that it will charge up C1 and C2. But in a particular capacitor, it has two stable state. So one capacitor voltage is always greater than another, whatever may be the less voltage, but that voltage will be charged up very quickly compared to other one, and then it will retain its state, whether it is 0 or 1, and it will maintain its voltage level so that it can be act as a dynamic resistors, dynamic cell for storing the data 1 or 0. And now you consider this refresh interval basically is of the order of microsecond, is of the order of microsecond, on interval is of the order of microsecond or less, and it's occurring in a interval of millisecond. That's mean is period is of the order of millisecond, but on interval is of the order of microsecond or less. So it consume power only within that microsecond region compared to its total period. So the power consumption is less. So heating effect is also less in dynamic RAM, and it is highly density. So these are the advantage of dynamic RAM compared to your static RAM. But the disadvantage is it cannot operate below a certain frequency range. It cannot operate below a certain frequency range, because if it operates below that certain specified frequency range, then it's one step to the zero state voltage or near about zero stage voltage, then it will be impossible to distinguish the data. So it can operate with a certain specified frequency. So that is why when you purchase the dynamic RAM, you will specify the frequency which is compatible for your computer. Now you come to another thing, that is charge coupled device. So in charge coupled device, it is basically a huge number of electrodes is there, and it is being used as a very high speed memory circuit, and it is used in maybe digital camera, your cell phone on, or any other high speed devices. Now in CCD, it has huge number of electrodes which are connected by certain non-overlapping clock signal. For simplicity, I will first mention you that three-phase CCD. In this three-phase CCD, you can see these are the electrode, and the uh, first, fourth, then 7, then 10, these are electrode are connected with clock signal phi 1, 2, 2, 5, 8 are connected with phi 2, and 3, 6, 9 are connected with phi 3. So these phi 1, phi 2, phi 3 are non-overlapping clock signal, and this clock signal has non-zero on and off period. Non-zero sorry, this clock signal has uh, non-zero rise and fall time. It has non-zero rise and fall time, and these are non-overlapping clock signal. That means the clock, when one clock is present, the other should be off. If one is in on state, then other will be in off state. That indicates the non overlapping clock signal. If a potential is applied, suppose phi 1 is present and phi 2 and phi 3 are off, then the potential well will create below the electrode of uh, phi 1, that is 1, 4, 7 and 10. The potential well will create below the electrode 1, 4, 7 and 10 when phi 1 is present. If phi 2 is present, then potential well will create below 2, 5, 8, right? And so on. So when this potential well will create, then if you introduce some charge in this potential well, then this charge will move freely, but it cannot escape from this potential well. So this charge can be considered as your data. Now how we will do this? And it will be shifted. This charge will be shifted from one electrode to another electrode. That means if phi 1 is on, then potential is created below the phi 1, that is electrode 1. Then this charge will be stored in that potential well. And when phi 1 goes to its low state, at the same time, phi 2 start to increase its potential, and the potential well will create below the electrode 2. That means charge of charge in the potential 1 of electrode 1 will shifted or transfer to the potential well created below the electrode 2. And then when phi 3 will be on, then potential well will create below the electrode 3, and the potential well at electrode 2 will reduces, and the charge will be transferred from 2 to 3. And like this way, charge will be shifted from one electrode to another electrode, and these three electrode can store the bit 1, right? These three electrode can be considered as to store a bit 1 or bit 0. That means number of number of electrodes per bit is 3. 3 electrode is responsible for storing a particular bit, either 0 or 1. Now how to introduce the charge? That will depends on your input signal. That input signal can be given with the arrangement by introducing one and one source. So here you see we have considered a silicon P substrate on which some layer of SiO2 dielectric layer is given. After that, electrode are produced. This electrode are may be considered as aluminum electrode or some alloy. Now below you see in first, that is a source and gate. Source, gate and electrode 1 can be considered as a transistors. Initially, the source, gate and electrode 1 can form a transistors. So by applying potential phi 1 and suitable voltage at source and gate, then we can create the potential well below the electrode 1, and the charge will transfer from source to the electrode until and unless the potential well below the electrode 1 is filled with the carrier electron, right? So under this condition, it will be charge will be shifted to the electrode 1. If your data is absent, then the source voltage, accordingly you have to choose your source voltage so that no charge can flow, right? So by flowing the charge, by controlling with gate and by applying the suitable voltage as S, then we can consider that charge will transfer to electrode 1, or charge will not shifted below the electrode 1. So like this way we can consider, or we can introduce the charge. The presence of charge we can consider bit 1, and absence we can consider it is 0. So now you can understand that this charge will be shifted from one electrode to another with the application of potential OL by applying the potential OL from the clock signal phi 1, phi 2, phi 3. And these three electrode, that is 1, 2, 3, can store a single bit. And this clock signal phi 1, phi 2, phi 3 are non-overlapping clock signal. That means no two signal or more than one signal cannot be high at a particular time. So that means the phase difference between any two consecutive signal is 120 degree. That is the structure and operation of three-phase CCD. Now we consider the two-phase CCD. In case of two-phase CCD, only two clock signal is needed, and then potential OL creates. Suppose, for example, here at t equal to t1, the potential OL is present below the 2 and 4. And in both 2 and 4, there is a charge is present. Now, after one period, this charge will be shifted to 3 and 5. That you can see by changing the uh, clock signal. That's mean phi 1 is reduces and phi 2 is increasing. So when phi 2 is reduces, then this charge will present here, and similarly this potential OL below 3 is increasing. So then what will happen? This charge will be automatically shifted to this electrode. So after this particular period of time, particular period, that charge will be shifted from 2 to 3. So this two electrode is responsible for storing the charge, a single bit data, that is the charge, either 0 or 1. So these are called the non-overlapping clock signal, which is defined by this. It is 180 out of phase because only two clock signal is used here, and this two-phase CCD is more dense device compared to your three-phase CCD. Right, so you will read these things. I have already shared this information to you. Point is clear?
Yes, sir.
So this is your syllabus.
Sure.
Up to this, you have to read your for final examination. In final examination, you have to 60 marks, out of which 30 marks will be a multiple choice question, and 30 marks you have to write in your paper. Then you have to scan and send in a particular email ID. That email ID will be provided to you, and at the same time, when you will scan the your answer script, then your answer script file name will be your roll number. Your roll number, you will give the file name of your answer according to your roll number in all capital letter, right? Your, that is CSC in capital letter. According to your roll number, you have to give the name, and then you have to send in a particular email address. That email address will be mentioned in your question paper, right, within a stipulated time. Do you want to need anything to ask me regarding this?
Sir, can you confirm now that what portion will be multiple choice and what portion will be subjective?
That at present we cannot say, but I can say you that questions will be in such a way so that you will not get the answer from note. You have to work out something, or you have to or think about, then you have to answer. It is not state card, that is, it is not defined or not described, right? Question should be something like analysis or synthesis. This type of question will be set because it is open book examination, so you can use your book, note, copy, everything else. So that type of questions will be set.
Okay, sir.
Next, anything else?
No,
Sir,
sir.
the duration is only 2 hours. So will we get the time? Like question is of 60 marks. Normally we get 3 hours.
No, because in this question there will be no description, right? So if it is a problem, then you have to use calculator. So it will save your time. Another thing, if it is a description, then you describe graphically. So you have to draw the figure and then you will mention. No need to write like a history. You don't write. You try to give it brief answer by graphical representation or by drawing like that. And it is also freehand. No need to use scale or ruler. If it is no need. Only you have to use the pen. Then you have to do it. Right. So that question will be such that it will be answer within 1 hour and 10 to 15 minutes, and you have to give him 2 hours time for writing. Then 15 minutes extra time will be given for scanning and uploading. Uploading means for mail, to mail it.
Okay, sir. Thank you, sir.
Okay, time will be sufficient. If you don't waste your time during the examination, then I think it is sufficient time to complete it. Anything else? I think all are okay.
Yes, sir.
So wish you all the best for your examination. See you in the next
Thank you, sir.
semester. Thank you
Thank you,
all.
sir.
Thank you, sir.
Thank you, sir.
Thanks.
Thank you, sir.